You're listening to the American Home Contractors Podcast.
So we're here with Patrick Aaron of Total Comfort. I met Patrick through Wade Sewell, who was on a previous episode of ours, talking about incentives for geothermal and solar. And now we're going to talk more about geothermal, diving into what it is, and then also talk about you and your company and the history.
Sure.
So Patrick, could you tell us a little bit more about yourself?
Yeah. So, as you said, my name's Patrick Aaron. My parents started Total Comfort about 28 years ago. And we've been doing geothermal for basically 28 years. Have installed nearly 1,300 geothermal systems. So it's something we're really passionate about. And I think we've kind of grown the excitement within our company. So our guys are excited about it. So yeah, I mean, and with all the new incentives, which you've probably touched on with Wade, I mean, there's never been a better time to be thinking about geothermal. So it's exciting for us.
So what is geothermal?
So geothermal, the best way that I think about it is it's a ground source heat pump. So you're still using electricity, but you're using the constant temperatures of the earth as your heat source or your cool source, as opposed to with a traditional heat pump where you're using outdoor ambient air temperature. So why geothermal system is so much more efficient is it's capable of, bringing 53, 55 degree temperatures year round to heat with or to cool with, as opposed to, 10 degrees while it's really cold outside or 95 degrees when it's really hot outside. So it's a ground source heat pump, typically can tie into a traditional regular duct system, which makes it really easy for retrofits.
So for folks that, like a lot of our team doesn't really understand when someone says geothermal, they're like, what does that mean? I get a lot of people think of the earth, right? Using the temperature of the earth, but how does that really work without getting too technical? Like a layman's terms, how does it work, geothermal compared to regular?
So there are really two ways to do geothermal residentially that we look at. One would be a closed loop system where you're actually burying pipe in the ground, you're circulating fluid through that pipe, and then you're taking it in and then sending that water into the house. Another would be an open loop system where you're actually taking water from the aquifer and sending that in and capturing the heat or the cool from that water as well. So closed loop, open loop. And really, then all you're really doing is send it into the mechanical equipment traditionally in the basement.
Gotcha. So with geothermal, it's more efficient because you're taking the warmth of the ground, which is 53 to 55 degrees, right? And you're taking that and you're turning it into 70 degrees, give or take, inside the house, right? So that delta is a lot different than if it's 10 degrees outside in the winter or 95 degrees out in the summer, right? So that's why it's more efficient, just taking a different temperature difference. Okay, cool. So what kind of wells are there? Because I know you can have like a horizontal well, vertical well.
So closed loop, there's really two common methods in our area. One will be a vertical closed loop where they're going to come in and drill vertically. Typically, bores of around 300 feet bore also is a well or a hole. So 6-inch bore, about 150 feet deep per ton. So the average house in Maryland maybe is a 3 to 4 tons. So you're drilling 450 to 600 foot in maybe 2 to 3 holes. The other closed loop method would be a horizontal where they're actually going to dig a 6-foot trench and lay pipe in that and then backfill and leave it mounded, usually for natural compaction over time. Horizontal back in the 90s and early 2000s when new construction was really taking off was very popular because you didn't have an established lawn. You go in, all part of the job. As retrofit has taken over with the incentives and people looking to improve upon fossil fuels and things like that, you're seeing vertical become much more popular because it's very, very minimal intrusion. You're coming in and drilling 2 or 3 holes that are 6-inch in diameter, and really there's minimal cleanup. Whereas with the horizontal, you could have a couple trenches sometimes the length of a football field. So you need a little bit of land. Now, with that being said, we go into pretty dense populated city areas and we're drilling in the front yard the size of the room we're sitting in right now. But typically with a horizontal, you need probably at least an acre, but we have to, based on different jurisdictions, we need to stay a certain amount of distance from your septic, from your well. So when you put all those things together, the amount of space that a horizontal takes can be kind of difficult to find the right yard to accommodate a horizontal.
Gotcha. So
whereas vertical, you can go in anywhere almost and find a spot to drill a bore or two. But both are very viable and are a great solution. And then the other would be an open loop, kind of how we talked about. You would come in and drill like you're drilling for a water well, and you're looking for a certain amount of water to extract from the earth for your geothermal system in that scenario.
So with the open loop, you can use like a pond or something like that, right?
So open loop, so we do pond loops, but traditionally with a pond loop, we would actually put coils of pipe in the ground, in the bottom of that pond, and use that. A pond you wouldn't necessarily want to use as a geothermal source because one, the water could maybe not be so clean, and two, we need to deposit it back into the same place. So usually you want to, if you're going to do an open loop, you want to make sure it's a clean, constant water source. Whereas a pond can be a little volatile in terms of maybe what's going in there, with animals and fish and things like that. So there are pond loops, and we've probably done, 10 to 15 over the years. But traditionally what we're doing in that scenario is taking a little kayak or a rowboat out into the middle of the pond and actually dropping coils of loop into the bottom of the pond where you have a constant temperature down at that 8 to 10 foot depth. Closed loop is much more common, especially nowadays with different environmental regulations, drilling regulations, things like that. Plus closed loop, you're really installing your own private utility in your yard that's really going to be there for the rest of the life of your system. Whereas with an open loop system, there is a little bit more concern with water quality, water quantity. Whereas with a closed loop system, you know exactly what you're putting in there. It's an established depth, an established flow, and really you're good to go for the life of the system. And then some.
When I had my geothermal installed, they ran into a situation when they were digging the vertical well. They hit some rock or something, and the well driller was just having a tremendous time trying to get through it. So they actually had to stop drilling that hole and form another hole. Is that pretty common, depending on where you live?
So in our area meaning kind of west of the bay, really drillers are more equipped. They want rock. What can sometimes cause issues if you have cavernous rock or caves or mud seams, because we need a substantial material to kind of keep that bore intact. So the issues they ran into there may have actually been like fractures in the rock or voids or something where everything was just caving in on itself.
Gotcha.
So that is rare. But really drillers around here, they want rock. They want to hit rock as soon as possible. And if they can stay in, solid rock 300 feet, that's exactly what they want. What they don't want is those voids and caverns where the loop really has nowhere to go. So when you drop the loop in, it may just kind of, wiggle all over the place.
And maybe that's what happened too. Maybe it started caving in.
It could very well could have been
on itself.
Yeah.
So where do you determine these wells to be dug?
So we'll take a lot of things into account. One, we want it to be as close to the house as possible, just because minimize the amount of intrusion and excavation and keep costs down. But like I mentioned before, there are things like distance from septic, distance from water well, distance from neighbors' property lines, distance from the street. When I go in and look at a project, I'm usually looking at minimal intrusion, minimal mess, but meeting all those distances. So a lot of times we find them in the front yard, just right off the driveway, so you don't have to do a whole lot of damage. But I mean, we've put them in backyards, side yards, under tennis courts, under driveways.
Under tennis courts, how do you do that?
So basically, you would go in before the tennis courts in.
Okay, gotcha.
Yeah. We would go. I mean, there's actually geothermal ground loops under parking garages down in Laurel. So yeah, you can do anything. You can drive over it. Just nothing that involves a footer. So so really minimal intrusion, meeting those minimal distances is what I'm typically looking for.
And what's the typical cost of the wells compared to the overall project?
So I'd say the wells usually account for probably 30 to 40% of the overall project.
Big part.
Which is kind of, I think initially when the tax credits first came out, whatever it was, 15 years ago, I think the theory behind that was, let's offset the cost of the ground loop. Because yes, geothermal is more expensive than traditional air-to-air equipment, but not significantly. So if we can offset that ground loop, we're really putting geothermal in more of a level playing field.
Gotcha. Yeah, that's the incentives have definitely helped it become more viable these days,
sure.
right?
For sure. Yeah.
So speaking of the wells, now we're going into the actual equipment in the house. Mm-hmm. So from the wells, we have the closed loop, which is most common.
Yes.
It's filled with what kind of liquid?
It's 80% water and then 20% what we call environol. It's really environmentally friendly antifreeze.
Okay.
It's like ethanol, like food grade ethanol.
To prevent it from freezing.
Yeah, for freeze protection.
Gotcha.
Yep.
Now, it shouldn't really freeze in theory, right? Unless it's like close to the surface.
Correct. So it should not freeze. It's really there. So at the end of a really long cold spell, when you're extracting lots and lots of heat out of that loop, you can drop the loop temperature, maybe down into the 30s and 40s, which is rare, but we want to have protection there in that scenario. Or maybe a scenario where somebody's a snowbird and the house is, left vacant for periods of time over the winter and just kind of sitting there dormant. We want to just have an added level of protection there.
Gotcha. Now, is the temperature inside the earth the same more or less depending on where you go? Like, is it?
It varies geographically as you go. As you go further south, obviously you're going to have a great little warmer.
Okay.
But usually in Maryland, 53 to 55 is what we tend to see, even up in the PA, West Virginia. In this kind of mid-Atlantic region, I guess we'll call it, we're going to see usually 53 to 55.
And that's once you go 400 to 600 feet down into the earth.
Well, really, once you get below about 6 feet, you're going to get pretty consistent.
Really?
Which is why horizontal is a viable option.
And how far down do you go for horizontal?
Horizontal, 6 feet.
6 feet. Wow. Okay, that's not much at all.
Yeah.
But I'm thinking like maybe in some place like Minnesota, you would probably go deeper than 6
very
foot.
different equation. Up there, so in Maryland, we're typically going to drill about 150 to 160 feet per ton of system capacity, whereas up in Minnesota, I don't know for a fact, but it may be double that. They're going to need more loop in the ground to offset their colder winters and their ground temperatures.
Okay.
Yeah.
So the well keeps the water, the liquid, right?
Mm-hmm.
The same temperature more or less throughout the year,
Yep.
53, 55 degrees
give or take.
in this area.
That's a good average. So you may see at the end of a long cold winter, the ground loop may be down into the low to mid 40s, and at the end of a long hot summer, it may be in the upper 60s or low 70s.
Okay.
So on average, the loop's going to be right in that mid 50 over a 12-month average.
Gotcha. So we're taking that water and we're putting it into the system, right?
Yep.
And then what's that process look like?
So really, the equipment itself is not going to look a whole lot different than a traditional air-to-air air handler or furnace. Typically, the equipment is in the basement. We would have a series of pumps that would be able to be maintained in service at ground level, or eye level, I should say, where we can service the pumps there. So there's no pumps in the ground like you would think about like with a well pump. It's not a submersible pump. The pumps are right there at the equipment. So basically we would connect the equipment to your existing duct system or a new duct system if it's a new construction project. And then those pumps are going to circulate the fluid through the heat exchanger inside that heat pump and then back out through the ground loop. So there's really two different types of geothermal systems, really three. There's a package system where everything's all in one nice chassis, one nice cabinet in the basement. There's a split system for situations where you have an air handler in the attic. So you would have the compressor, the heat exchanger, kind of the brains of the system in the basement. And then you have refrigerant lines like you would with a conventional air-to-air system to an air handler, like in an attic or a crawl space or something like that. And then the other scenario would be a water-to-water, where you're actually having a ground source heat pump that would heat hot water, whether it's for a radiant floor application or for domestic hot water. So the equipment itself, it's almost appliance-like in appearance. There's no outdoor equipment with geothermal. Everything's inside. It kind of looks like a small compact refrigerator. In a lot of cases, less intrusive than air-to-air equipment.
Okay, so you can take the compressor that was outside previously and pull that out.
Correct.
There are situations where you would need a compressor outside though, right? Like you said, if you have the air handler inside the attic or something.
Well, no, in that split system scenario, that split system could still be in your basement or crawl space.
Oh. Okay.
They make an outdoor geothermal split unit, but they're rarely needed. And maybe in different areas, different parts of the country where you don't have basements or crawl spaces and you're on a slab, they're a little more popular there because they could then just bring the ground loop directly to that outdoor unit and then connect everything inside. But where we are, where you traditionally have a basement or a crawl space, we try to get everything inside out of the elements to prolong the life.
Okay. And as far as the equipment's concerned, there's one major manufacturer that most people use, right?
Yeah. So Water Furnace, they've been at it since 1983. They're out of Fort Wayne, Indiana. Fantastic company. Yeah, they're, in my opinion, they are the lead dog in the geothermal game.
And what makes them like better than everyone
so
else?
There's a lot of things about Water Furnace that I could speak highly about. One would be their dedication to innovation. They're constantly trying to improve product. Two would be their connection to their dealers. So we've been a dealer for 28 years, and I could go to the Water Furnace plant in Fort Wayne, Indiana, and probably know half the people at that factory. I've had dinners with the CEO and also the engineer, but also the lady that works customer service. So I always say that Water Furnace is big enough to kind of handle anything you throw at them. but they're small enough and intimate enough that you have a very personalized relationship. So if you're having an issue, I could pick up and call the head of engineering and do a cell phone and be like, oh, let me run down to the floor and see what's going on there. So I can't speak highly enough about Water Furnace, and their dedication to innovation and their customers and to the renewables, the renewable industry as a whole.
That's awesome. And they have like good technology too with like monitoring the system as well.
Yeah, so they have a system called the Symphony, which kind of provides the ability to remotely monitor and troubleshoot the system. So for the homeowner, that gives you the ability to see energy usage, control temperatures, change operating mode. But for me, the dealer, it's invaluable because I'm able to remotely troubleshoot the system, see everything the unit's been doing for the past 12 months. I can get in and make adjustments. Oftentimes, I know the homeowner may or may not need a service call before they do. I'd say 20 to 30% of our service calls don't need to require a service call because I'm able to hop on my desktop or on my iPad and remotely troubleshoot the system there. Give the homeowner a call and say, hey, I made a few adjustments. Give it a day or two. Check back with us. It's great. It's great stuff.
Kind of a weird question, but I didn't know when I was going to ask this question.
Right?
Oh, there's no such thing. It just keeps bubbling up in my head right now. Just because when I was talking about geothermal to somebody, and in particular this area, they were like, "Oh, I didn't know you had a volcano nearby." So I said, "Oh, interesting."
Right.
So some people associate volcanoes with geothermal, and I think El Salvador has a volcano that they're using tap into for energy, and
right.
I think they're mining Bitcoin and other things like that.
Yep.
Can people use volcanoes?
In that case, we're looking more on the geothermal energy power side of things. So in this scenario, all we're really doing is using the earth as a heat sink.
Okay.
So really, so geothermal is a term that's used. Ground source heat pump is a term that's used. So when we're thinking, volcanoes or, high temperature earth locations, speaking geothermal in that term, different ballgame.
Yeah, it's not. Is it really considered geothermal?
So I guess they're both considered geothermal, but one would be a geothermal heat pump, whereas the other would be a geothermal power supply.
And how do they use the heat? Just like to
in that scenario,
steam?
they're extracting heat from the earth and basically converting that to energy.
Okay, through like boiling water, steam,
I'll be honest,
turning turbines, that kind of stuff.
I have no idea.
Okay.
Somebody smarter than me is going to watch this and be like, that guy doesn't know what he's talking about.
It's just interesting.
But yeah, no. So they're actually, I believe it's down like around Charleston, West Virginia. If you look at different heat maps of the United States, there's an area down there that I've read at one point could energize like half the eastern seaboard.
Wow.
But I just don't think it's ever been tapped into or used. But it's fascinating, but honestly, it's a different game and something that somebody much smarter than me would have to answer that.
Okay. Yeah. I was just taken off guard when I was talking about that, and they were like, I didn't realize there were any volcanoes nearby. I was like, whoa, okay.
Yeah.
Wow, there's the awareness.
Different beast.
Different beast.
Yeah.
Okay, so can you tell us a little bit more about Total Comfort?
Sure. So like I said, we're a family business, been around for about 28 years. 5 of our 17 employees are family members. So I have a younger brother in the business. My mom and dad are both, involved in different degrees at this point. My aunt's our service manager. And a lot of our guys have been with us, 15, 20 years. So we have a really good core group of guys who have very similar values, customers, at the forefront, customer service at the forefront, energy efficiency at the forefront, whether it's geothermal or other options. But we travel about an hour radius of Hagerstown, Maryland, predominantly for geothermal. Yeah, so that's really, we're passionate about geothermal. We're passionate about customer service and really energy in general, using it as efficiently and as responsibly as possible.
We have some joint customers that we've installed Tesla Solar Roof for. You guys have helped them go geothermal.
Absolutely.
I believe they all went geothermal more or less at the same time or previous to going solar.
Similar, yeah. Yeah. So it's they're really the perfect marriage.
Yeah.
It's the perfect marriage because, typically heating, cooling hot water is going to account for 60 to 70% of your energy usage. So if you're able to reduce your energy usage significantly via geothermal, then couple it with a solar roof, Tesla system, wherever the case may be, it's really the perfect marriage to get as close to, net zero as you can.
Yeah. Solar on the production side, geothermal and reducing the consumption side of the equation, which is great.
For sure.
Now, in your experience working with homeowners, What are the reasons that these folks are going geothermal?
It's all, I've seen it all, so I have some customers that it's 100% environmentally driven. They don't care about the return on investment. They don't care about the financial side of things. They just want to feel like they're doing something that's environmentally responsible. I have some customers that it is 100% financially. They're spending $8,000 a year on oil. They could care less about the environmental impact of that oil. They just want to save significant amount of money. The majority of our customers are somewhat in between. They want to, do something that's financially and environmentally responsible, but it needs to make sense, financially. Quite honestly, I've had some customers that have put geothermal in just because they didn't want to have an outdoor unit. So their outdoor units are currently sitting right beside their patio. That's where they have happy hour, and they don't want to hear them. So, but I would say the majority are people, a combination of looking to save green, whether it's green cash or help the environment. It's a combination.
Now, the folks that are 100% financial, because we deal with this on the solar side, does it make a lot of sense when you factor in the incentives?
Oh, yeah.
Does. And what's the payback period?
So it really depends on what you're comparing against. Obviously with the volatility of propane and oil prices today, I've seen return on investment in as little as 2 or 3 years. Average return on investment of a geothermal system is probably in the 4 to 7 year range. That was a little bit longer before the GRECs came out, which I know you've talked recently about with Wade. GREC meaning Geothermal Renewable Energy Credit. So that has definitely boosted the ROI. But I would say the average homeowner is a 4 to 7 year payback. And then from there, really, it's making money. Because the geothermal system, the equipment itself should last over 20 years. The ground loop's going to last the rest of our lives. So really, we're replacing systems for people that we put in for 27, 28 years ago, connected to the exact same ground loop.
Wow.
They're getting all the same incentives we've discussed. And they're getting a new geothermal system for cheaper than they could go get a 14 SEER heat pump after the incentives.
That's awesome.
Yeah.
With folks, the average price of a geothermal unit would be, or project? Average,
I would say probably 30 to 35,000 before the incentives.
Okay.
Yeah.
Pre-incentives. So what are the incentives?
So it would be a 30% federal tax credit. In Maryland, you would get a $3,000 Maryland clean energy rebate. Utility companies, depending, will give you anywhere from $1,500 to $3,000 per system, which means if you had a 3-system home, that could potentially be a $9,000 instant rebate.
Wow.
And then the GRECs as well, which are kind of variable depending on size of your home, the type of heating system you're replacing, things like that.
Yeah, we dove into GRECs with Wade, but on average, what are the GRECs? What's like the typical value?
So the value of a GREC currently is right around $90 to $99 a piece.
Okay.
Average house in Maryland is probably going to get somewhere between 30 to 40 GRECs. So we'll say $3,000 to $4,000 per year. I just looked at a project for a homeowner. Actually, just finished a project. He was going to get 135 GRECs per year.
Oh,
you do the math on that. That's like $13,000 a year.
And there's no cap.
No cap.
No cap.
No cap. So and that's what the kids say, right? No cap. But what was I going to say? That's corny. So I mean, yeah, in that case, he had a 6,000 square foot house he was probably spending $9,000 a year on oil. So you take the energy savings, GRECs, and everything else we just talked about. I mean, his ROI. It's a big job. It's an expensive job, but his ROI is still probably gonna be less than 5 years.
That's unbelievable. Yeah. Since it makes so much sense. Like for us on solar, there's a lot that goes into that, like orientation, how much sunshine hits the house with shading and all that stuff. But for you, for geothermal, it seems like it makes financial sense for most people.
It really does. I mean, the range of customers that I have found over the past few years is very wide. We could have the single mom off of a single income home, to the McMansions. Very wide spectrum, but in most scenarios, you can make geothermal make sense financially in almost any scenario with some of the really neat financing programs that are available these days that allow the homeowner to take advantage of the incentives without really having to outlay any money before that. And that's both through independent credit unions and even the state of Maryland has some nice financing programs available as well that'll assist.
So what does that look like if you're getting a $35,000 system, you're getting all the incentives,
right,
and then you're also taking a loan?
Right. So, the state of Maryland has a program called Clean Energy Advantage. Well, they actually will finance up to $35,000. The first 2 years are 0%. And then you have a term loan after that. But you think about within that 2-year period, you're going to get all those incentives back. So $35K, you're going to get 30%, $3,000. So, at the end of the day, what are you paying? Half of that, we'll say, essentially. So now you're only financing $17,000 over a 8-year period. Which in a lot of cases was like a cell phone bill.
Mm-hmm.
And then you're maybe saving $300 a month on oil. Another program that we use a lot is it's called a combination loan. So you would basically do a balloon loan on your tax credit amount, get that money back, pay that balloon loan off, no monthly payment required. Then you're just left to finance the other 70% of the project on a term loan. Typically on those loans, there's no prepayment penalty. So as you're saving money on your energy, you basically are just paying off the loan and closing it out.
Awesome.
Yep.
But let's talk about something interesting with geothermal that most people don't know about. The hot water assist.
Yeah, hot water assist. So one of the big benefits of geothermal is, obviously it heats and cools your house, but while it's heating and cooling your house, it has the ability to supplement your domestic hot water. So as I mentioned before, heating, cooling, and hot water are the 3 biggest energy users in your house. So if I told you every time your system's cooling your house, you're getting free hot water as a byproduct, people are like, wow, that's a big savings. The average family of 4, I think that results in a savings of about $300 a year just in hot water savings. So basically all the way that works is we would just plumb from the geothermal system, usually to an existing hot water heater in a lot of cases. So every time the system's heating and cooling your house, we're just sending free hot water over to your water heater. With the goal being the elements in your water heater don't have to come on as often, which is going to save you hot water.
That's awesome.
Yeah.
And why don't most people know about that?
I think it's just, honestly, in general, a lot of people don't know about geothermal. They've heard about it. They hear it's expensive, but that's really the end. They think it heats and cools the house. They don't realize everything that's capable of doing. So I think it's just a lack of knowledge, but that's not their fault. That's the industry's fault. That's our fault, which I think it's improving. Just informing homeowners of all the things that geothermal is capable of doing.
Mm-hmm. Do you think if more people were aware of it, more people would be going geothermal?
Oh, I think so for sure. I think like we've talked about the incentives, the return on investment, the ability to heat, cool, and provide hot water. Those are 3 things that are become pretty essential in life these days.
Mm-hmm.
So I think more and more people, if they were informed of the capabilities of a geothermal system and the financing we talked about and the incentives, I think it would make sense for a lot of people. And you would see the popularity grow, which we have. I can't say that we haven't, but it's been a gradual process. Like I said, water furnace has been around 40 years, and really, it's in the past 10 years, maybe or 15 years, we really see it really start to take off.
And you guys are one of the top installers for a water furnace, right?
Yeah, I think this year, Little Old Total Comfort in Hagerstown, Maryland. I think we were the ninth dealer in the nation in terms of installations across the country. So
that's awesome.
Yeah,
Congratulations!
Awesome. Yeah, thank you. That was quite an achievement for us, considering where we've started and where we've grown from. Still being a relatively small family business, it was something we were pretty proud of.
And this is one of the best areas for geothermal?
Yeah, I think not only because of the geographic area, the ground temperatures, but also the incentives, really help in our area. Obviously, our location to DC, it's not only income levels, but also maybe a little bit more proactive mindset, forward thinking helps as well.
Mm-hmm.
But yeah, the Maryland area in general is a popular area for geothermal, and I think the incentives have helped with that a lot.
And when people are going geothermal, is this usually the first step they take towards going green, or are these folks already like into solar and electric vehicles and that kind of stuff?
I see both, and solar guys probably hate to hear me say this, but in my opinion, you should go geothermal first, because you could then see how much your energy strain has reduced, and then it makes it easier to size a solar system.
But wait a minute. If you reduce your consumption and the utility companies are basing your system size on your annual consumption, then you might not be able to get a bigger solar system size
point.
if you're not capped.
That's a valid point.
Yeah. So I always thought, you want to you want to try to go solar when your electrical bill is as high as possible, because then you can get the biggest system as possible.
And then for me, all I'm looking at is you want to put the smallest system in as possible, across the board. But no, so yes, I'd say it's 50-50. A lot of times they already have solar, they have an EV in the driveway. Those are the ones where you pull up and you're like, all right, this is a slam dunk. But no, I would say it's 50-50. Greater than half of our customers, if they haven't, already kind of dove into that renewables, whether it's, solar, wind to a lesser degree, EVs, geothermal is oftentimes kind of the start for them. Because a lot of times I'm going to look at a job and they may have a gas furnace or a heat pump there now. And I'm like, did you ever think about geothermal? They're like, what's geothermal? And then we kind of start talking about it. And then they're like, oh, this opens up a world, that I didn't really know about. I'm like, so yeah, it's a renewable energy that a lot of people don't think about. They don't think about the fact that the earth is a renewable energy source. We know the sun is, we know the wind is. So a lot of times it starts that renewable energy journey for people.
Yeah, and it's amazing how much electricity those electric vehicles consume. Yeah. Which is, know, if you have, and people that have gas, right? They're not seeing that in their electrical bill. So once they switch from gas or oil over to an electric heat pump, then they see that as part of their electricity use. And then, of course, you add an electric vehicle or two, then your electricity consumption is off the charts.
Right.
So like it's kind of challenging when you're working with different utility companies because they only allow you to have a certain system size. So it's like, man, it's like a lot of them aren't allowing people to build up their system sizes big enough to accommodate the additional electricity going from gas, oil to electric heat pump, going from combustion engine to electric vehicle. So it's unfortunate on the solar side of things, right? But I hear you with going geothermal first and foremost to pull down your consumption. I do think that solar and geothermal should be married together.
100%.
We're trying to encourage a lot of our customers. Yep. It's a big expense, especially if they're going solar roof, and then to add on the geothermal in a short time frame. It's a lot.
It is a lot. It is a lot in a short time frame. So in a lot of cases, you'll see somebody, all right, I want to do this. I'm going to do the solar now, and 5 years from now, I'm going to do the geo or vice versa. But yeah, they're the perfect marriage. And I think as time goes on and we obviously know about strain on the grid and the grid's capabilities, I think you're going to see it become more and more popular, where people are looking to, not necessarily be grid independent, but doing as much as they can to reduce their strain on the grid for potential load shedding and things like that we may see in the future.
Now, when you guys install a geothermal unit and they have solar, maybe they have batteries as well, how do you figure out what panel to put the geothermal on? Do you guys do like load calculations and stuff like that?
So a lot of times it'll depend on obviously the size of the battery, how much battery they have. But we do have systems, whether it's a geothermal system with an inverter or compressor that doesn't require much energy to get started, or we put what they call an IntelliStart on every geothermal system that reduces the start load amps, which make it much more generator or battery friendly. But a lot of times we'll leave it to the electrician, for sizing wire and what's coming from what. But yeah, no, that's becoming more and more popular where we're seeing, geothermal systems interlocked or interfaced with battery backup.
And where do you see the industry heading?
I think that is where it's heading. I think not only battery systems, but just a full integration of geothermal with other renewables, whether it's battery backup, solar, all those things. From a geothermal industry standpoint, I don't really know where we go from here, because we have inverter compressors in geothermal systems now. Maybe we'll see like a geothermal mini split or a multi-split, in the future. That would maybe be where I could see the industry going, but I'm sure somebody will come out with something that'll blow my mind, a few years from now.
What about the ductwork in a house? So like, should you clean your ductwork in the house?
Yeah. So ductwork's one of those things that, it depends on the house, it depends on carpet, it depends on animals, it depends on kids. So the average duct system maybe should be cleaned every 10 to 20 years. But I usually tell people if they're concerned about it and they do have, dogs in the house and carpet, maybe every 10 to 15 years, think about getting it cleaned. Yeah. Just kind of a personal preference thing.
Because that's what I was thinking about with HVAC is like, you have these air purifiers like Dyson has and some other companies that you just put in a room and it purifies the air.
Yep.
Why can't we have that attached to the heating and cooling system and running through the ductwork?
Yep, that's becoming more and more popular. So actually, water furnace has a bipolar ionization system that integrates directly onto the blower of their system.
Really?
So you can do something very, very similar. So that is, so I hate to use COVID, but COVID really made our industry, think of ways to clean air, whether it's through ionizing air, purifying air, diluting air with fresh air.
Mm-hmm.
All those systems can be integrated into a geothermal system or really any ducted air source system for that matter.
And what about humidity?
Yeah, humidity is one of those things where every house is a bit different. During the winter time, if you have hardwood floor, you have instruments, pianos, things like that. If the house is too dry, it can affect those things.
Mm-hmm.
Even dry skin, dry nasal cavity, things like that. But every house is different. Ideally, we want to see a humidity somewhere in the 30 to 50% range, and then during the summertime, kind of the same deal. You may need a dehumidifier. Obviously, an air conditioner or a heat pump or a geothermal heat pump is a dehumidifier, but it's a dehumidifier that's satisfying based on a desired temperature.
Mm-hmm.
So, oftentimes a basement doesn't have a thermostat. Basement is usually the source of humidity. So you may need a dehumidifier down there to look at the house holistically, to get the humidity range where it needs to be.
Do you think in the future, because I know this will be tough for retrofit, but do you think in the future there'll be a time where there will be a thermostat in the basement and we'll be able to have everything we need from the centralized unit as far as the proper humidity in different parts of the house, the air purified in all parts of the house?
Yep.
Do you see a future like that?
So Water Furnace just released a system that actually has a built-in dehumidification system now.
Oh, wow.
So you'd be able to not only satisfy temperature, you can also satisfy humidity level now on the system.
Now, how does it pick? Does it have sensors in different parts of the house?
You could have sensors, you could have thermostats. So that's where it's going. So they call it the OptiDry 7 Series OptiDry. Huh. So it's the same 7 Series unit they've had for several years that heats and cools, but now you have the added capacity and the added capability to dehumidify through that same system. So you could do that. You could connect that ionizing, that bipolar ionizer. So now you've got indoor air quality taken care of, you got heating and air conditioning taken care of, and you got hot water taken care of. So that's definitely where things are probably going.
Now, taking the humidity out of the air is different than putting it in. Do you see that being something?
So humidifier is something that's a little different because I would say almost every house needs dehumidification to a certain degree, but not everyone needs a humidifier. So there may be a time where you integrate it into the system, but quite honestly, installing an aftermarket humidifier to an existing system is pretty common. So I don't know that we'll see that, but I'm sure somebody will think of it. There are a lot of good aftermarket humidifiers out there that can be tied into the duct system, for a whole house approach.
And now when you guys look at the ducting system with going geothermal, do you make sure that there's enough returns, there's enough?
Yeah, you definitely want to make sure we got enough airflow, but whether it's on the supply side, return side, that's all taken into account when we're looking into an existing duct system. Adequate airflow, enough return, checking static pressures, for optimal, because you don't want to just go put the best heating and cooling system in the planet on a, 45-year-old duct system that is grossly undersized or oversized. Because at the end of the day, that's what they're going to be comfortable with or happy with. Mm-hmm. Because if they have a great system, but they don't have adequate airflow to certain parts of the house, they're going to be unhappy. So at the end of the day, they have to be comfortable in their house. That's definitely something we take into account. Leaky duct systems are pretty common, especially in older homes before the state required certain levels of duct leakage. So we do have a product called AeroSeal, where we can actually seal the duct system from the inside out, which will help improve the airflow and improve the air quality, airflow, all those things.
Really? You seal it from, you just spray something in the duct?
Yeah, so basically, AeroSeal has been around now for, I'm going to guess 15 to 20 years. So basically it's a product where we go through and we block off all the supply registers and the returns in the house, and then we pressurize the duct system. And then we're going to basically spray a sealant through the inside. So it doesn't necessarily line and coat the ductwork. What it's looking to do is looking for areas of leakage and it'll coagulate and fill those voids. And it'll fill anything up to 5/8 of an inch, which is a pretty substantial leak. So it can typically get your duct system down below Energy Star standards on an existing 30, 40-year-old duct system.
So in your 28-year experience, with geothermal, what is the biggest innovation you've seen come from?
The biggest thing I've seen in geothermal and really the industry as a whole would be compressor technology. So 28 years ago, you had a single stage compressor, which was two things. It was off or on. A couple years later, you would see a two-stage compressor. Compressor has the ability to come on and run at 70% capacity or 100% capacity. About 8 to 9 years ago, now we've got variable speed compressors in geothermal systems. So that compressor has the ability to run, all the way down to a quarter capacity and everywhere in between. So the system really only runs as hard as it needs to based on the desired temperature in the house and the strain that the outdoor ambient is putting on. So I'd say that's the biggest innovation in our industry. Geothermal or really air to air for that matter is compressor technology has evolved so much, which has made equipment so much more efficient. So the best way I compare it is kind of like city mileage versus highway mileage on a vehicle. So single stage equipment is city mileage, stop, start, stop, start. Variable speed, yes, you're running longer, but you're doing it much more economically because it's doing it, in a less strenuous fashion.
Now, there is speculation that certain manufacturers are going to come out with different heat pumps and stuff for the home. Tesla's one of those companies that people think, since they've developed good technology in the cars, why can't they apply that technology into the house itself? So do you think that things can get even more efficient? And
I think things can get more efficient on the air-to-air side. But what I will say is that at the end of the day, a heat pump, an air source heat pump, is still converting outdoor ambient temperature to desired temperature in the house. So if it's 10 degrees, even if that system's more efficient, you're going to have a natural drop off in capacity and efficiency as it gets colder outside, or hotter for that matter. Whereas with a geothermal system, we don't care if it's 10 degrees outside. We're still bringing 53 degrees in. So yes, I do think that air-to-air heat pump technology will continue to improve and evolve. But I would say at the end of the day, I still think that temperature delta that we first talked about initially is what is going to continue to set geothermal apart, is the ability to deal with a much, much more consistent temperature for heating and cooling as opposed to trying to convert outdoor temperatures.
So geothermal is probably best in areas that have robust climate change, right? Like cold winters,
more so.
Hot summers.
It's extremely popular up in, you mentioned Minnesota earlier, New York, New England area, very popular. But it's all over the country. But I think people that really truly see 4 seasons is probably where it makes the most sense.
Is there a lot of adoption in like Southern California where it's like a consistent temperature?
Yeah. So, you're still seeing it out there, probably for different reasons. Maybe more just environmental reasons out there. Mm-hmm. Yeah, you're seeing it everywhere. It's extremely popular in Florida, which is mainly a cooling driven, climate. Yeah. But yeah, you're seeing it everywhere. And it's being recognized by jurisdictions everywhere, which I think is what a lot of it is. If your local power company or your utility company or the state or your county is not going to recognize it, a lot of times homeowners were like, well, what's the point? But I think even if the Carolinas have begun to really incentivize it, I think you'll continue to see it kind of grow all over the place.
Interesting. And are there any houses that you would like disqualify from geothermal?
Disqualify, no. At the end of the day, there's always a way to do geothermal. But I would say that there are scenarios where I may say, I don't know that this makes sense financially for you. If you don't have ductwork, if you're on a crawl space, there's no way to get ductwork in the house. It's a relatively small home with minimal energy usage to begin with. I may say, yes, we can do it, but it may not make sense financially. So I wouldn't say that would disqualify it. But I would be upfront to just say this may not be the most wise investment in your particular scenario.
Gotcha. So it's financial at that point. Feasible.
It's pretty much always where I always say where there's a will, there's a way, obviously. Mm-hmm. But yeah, feasible, yes. Does it make sense financially? Maybe not in this scenario.
And that goes for homes that are on the coastlines where the earth is sandy, and then out in the mountains where it's clay, that kind of stuff, or rocky.
No, really, that doesn't matter. So the same drillers that have rock rigs, they have sand rigs. So when you get east of the Chesapeake, they're drilling down along in Annapolis, down along Ocean City, down along all the time. So it's just different types of rigs, different types of approaches for drilling, maybe more horizontal. So we're seeing it everywhere. Not us specifically, but I know geothermal is very popular on the coast as well.
Has anyone struck oil in any of your geothermal projects?
No.
Okay, didn't know.
Unfortunately not. Yeah, or I guess
they just reap the
I
savings.
do have a pretty cool story though. One time, we were drilling a job, and they must have had an underground spring or creek or something. And while they were drilling, it started to drill artesian, which means it was starting to flow out of the top of the bore. And there was like crayfish and fish and everything flying out of the. So they like hit an underground creek.
Really?
Yeah, that was pretty wild.
What happened? How they
just kept going?
Kept going?
I mean, water is a great conductor, so as long as you can contend with that water and get your pipe in. So probably they hit it. It was probably only 3 feet deep. You just keep going through it, and then it's all good.
Wow.
Yeah.
That's interesting.
Yeah. Yeah, it was a different one. Like crayfish crawling out in the yard. Yeah.
Is there a noteworthy installation, a project that you would, like to share a story about?
It's a tough question. I'm thinking. We had a system we installed probably 12 to 13 years ago. It was a geothermal project, all radiant. So this was about a 15,000 square foot house, with all radiant throughout, all 3 levels, basement, first floor, second floor.
Wow.
We had over 1.5 miles of radiant pipe in that house.
Wow.
So we laid over a mile of radiant pipe in that house, and it is the most comfortable house I've ever been in my life.
Wow.
It's amazing. So I would say that, so that, like I mentioned, geothermal can heat and cool, heat hot water, but I think he told me 15,000 square foot house, I think their electric bill was like $200 a month,
Sheesh.
Yeah. That was a really cool project. That was the one summer where like the stink bugs like first came to our area. So like every day our guys were on their knees all day long, and they would get up and they just were covered in stink bug guts.
Oh.
So that part probably wasn't very memorable for them, but that was a really cool project that at the time I was like, man, you don't get a whole lot of those,
Mm-hmm.
That's cool.
Yeah. And I'm assuming that most of your customers, like ours on the solar side, are really cool people.
Yeah. That's the thing that sticks out. I was out to dinner like 2 weeks ago, and I had a homeowner come up to me and just tap me on the back, and they're like, you've made my husband so happy. And I'm like, what do you mean? Who's your husband? And then I turn around and see him. She was like, he just loves that system. It saves us so much money. I'll run to people at the grocery store, and he'd be like, hey, I know you told me I was going to quit chopping wood. He's like, yeah, I stopped like a month after you put the geothermal in. Just guys that are, split wood their whole life, and they love it because they love the heat of it. And I'm like, you're not going to need it after you get geothermal. System's so comfortable. And they're like, you're right. I haven't split wood in 5 years. So just little things like that where you run into somebody at the grocery store or out to eat. And there's nothing I like hearing more, honestly, that they're comfortable in their house and that we've saved them a lot of money. So that's really what it's all about.
Do you find that most people that go geothermal, do they increase the temperature in their house to make it more comfortable in the winter? Yeah. They do? Okay.
Yeah, so I always ask people that. They're like, yeah, well, I keep it 65 right now. I'm like, well, you keep it 65 because you're spending $5,000 a year on oil. So I'd be like, so when I design the system for you, what would you like your house to be? So I take that into account. Yeah, a lot of times they do. But the other thing you hear is that actually the quality of heating and air conditioning is so much better with geothermal that sometimes they actually keep the heat lower and the AC lower or higher, I'm sorry, because the air coming out of the vents now is so cool.
Oh, it is.
It's cold.
Yeah.
So what used to feel comfortable to you with an old air-to-air system is no longer the same. So a lot of times I hear the opposite, where they actually keep it warmer in the summer and cooler in the winter.
Interesting.
Yeah, you definitely see people who say, I'm only going to keep it 68, and then I'll go look at it on the Symphony, and they've got the heat cranked up to like 73 degrees on a 10-degree day. I'm like, yeah, good thing we sized it for that.
Well, we got to talk to my wife about that because she still keeps the house pretty cold. She's set in her ways, and we'll come down and we'll all be freezing. We'll be
this thing's efficient. We can be comfortable in our house.
Yeah, we'll be wearing sweatshirts and just like sometimes winter jackets.
Yeah,
like I'm in my office and I got a winter jacket on. I got a space heater in my office. I'm like, we went to geothermal for a reason
why did I spend
here.
This money?
Yeah, exactly. We got to crank that thermostat up in the winter.
Right. Agreed. Yeah, I see it all the time.
So, is there anything else you want to talk about? Total comfort? Any shout outs?
What I'm excited about, so we'll have the water furnace national sales meeting coming up. So I'm excited to hear about where the industry is going. But I honestly would be lying to you if I wasn't excited to get our first platinum award. So being at the top 10 in the nation in sales.
Mm-hmm.
So that's something I'm excited about. Like I said, not to pat yourself on the back, but I think it's a testament to the team we've built here. Because without, the guys that we have that are, working tirelessly to install these things, service these things, and keep our customers happy and building the reputation that we have built, none of it would be possible without the awesome team we've built here. So I think at the end of the day, I'm just really thankful for what we've built here, and just look to continue to grow it for years to come. I'm planning on doing this thing for quite a while. So
that's awesome.
I'm just looking forward to see where not only Total Comfort will go, but also just the geothermal industry as a whole.
Where can people find you online? And
so online, you can find us. Our website is asktotalcomfort.com, and phone number is 301-745-3700. And we're on all the social media platforms as well.
Cool.
Yep.
Awesome. Well, thank you for the conversation,
Absolutely.
Patrick. It was great.
Thank you. Appreciate it.
You've been listening to the American Home Contractors Podcast. You can find us across the web on YouTube, X, TikTok, and Instagram at AHCDMV. Thanks. We'll see you in the next one.